All right, so now we're going to be moving on from our just basic functions into the properties of these parabolas that we are going to be looking at. Okay, so we're going to be looking at some of the properties and how to find these without looking at the graph specifically. We're going to be looking at, if we're just given the function, we're going to be able to find the vertex and the y-axis and the y-intercept and all that stuff. Okay. Okay. So first thing to start off though is for graphing. And for graphing, the best way to graph these, one way to do it is by hand. And what you'll do is you just start picking numbers and start plugging them in. So as you see here, I pick 5 different numbers and then I plug them all in. So when I plug in a negative 2 squared is 4, plus 2 is 6. When I plug in a negative 1 squared is 1, plus 2 is 3. When I plug in a 0 squared is 0, plus 2 is 2. 1 squared plus 2 is 3. 2 squared plus 4, or plus 2 is 6. And so then I plot those points. I plot negative 6, 2, negative 1, 3, and so on and so forth. And as you see, there would be my graph. Okay? And that's one way of doing it, is that you just start picking points. Now, sometimes the problem is that you might not be able to find where the turning point is exactly just by plugging in numbers. I mean, the turning point, what if the turning point was over here? Then the numbers that you would get would only go from, if you pick these points, you would have only had it going to about here. You don't know where it's going to start turning back. And so being able to identify the different parts is what we're going to be looking at later on in this. Okay, looking at standard form. Now with standard form, the first thing we want to look at is the very first number. And if the very first number, the part that's attached to the x squared, or the quadratic term, if the quadratic term is positive, we are opening up. Okay, so it looks like this blue one right here. Okay, so if the quadratic term, or the very first term, or the part that's attached to the a squared, or the x squared, if that's a positive number, then it's going to be opening up, which means we have a minimum. Okay, we have a minimum in those cases. Now, if it's negative, so if we have negative x squared, that is when we have here, this bottom one, and we have a maximum, and it's opening down. So that's going to be the first thing you're going to want to identify. Whenever you're looking at these functions, you want to see, okay, is it opening up or is it opening down? Do I have a max or do I have a min? Okay. All right. Okay, your vertex. Now, your vertex can be found if you're putting it into standard form. It's just a little quick formula. Okay. The x-coordinate will be at negative b over 2a. And the y-coordinate would be, whenever you find that number, you plug it back into the function and see what you get. So, let's look at this one down here. If we want to find our vertex, what we're going to do is we're going to take negative, and then we're going to take the b value, 8, and divide it by 2 times the a value, which is 2. That gets us negative 8 over 4, which is negative 2. So that means in our answer, we're going to have negative 2 comma something. Okay, and now we got to find what that something is, what the y value is. Now, I'm going to take this negative 2 and I'm going to plug it in to the x values. So I have 2 times negative 2 squared plus 8 times negative 2 minus 8. Negative 2 squared is 4 times 2 is 8 minus 16, 8 times negative 2 minus 8, which gets us a negative 16, which means our turning point is going to be at negative 2, negative 16. Okay, and as you see there, there's the rest of it. But that's how you're going to find the vertex, is that you just plug it, you just find negative b over 2a, find what that number is, that's your x, take the x value, plug it back into the equation, and that tells you your y value. Okay? Okay, now, with your axis of symmetry, okay, and your y-intercept, what you're going to be looking at is your axis of symmetry is the exact same point as your x value for your vertex. So it's the same formula, but instead of just putting in a parenthesis, you're going to say x equals that number. And then your y-intercept is 0, comma, the constant. So when you're looking here at this function, our negative b would be negative 2. So it'd be negative 2 over 2 times 1, which gets you a positive 1. So that means that our intercept, or our axis of symmetry, will be at x equals 1. Okay? And now your y-intercept will be the c value. Our c value is 9, so that means our y-intercept will be at 0, 9. And we are done. Ta-da. Easy, easy, easy. All right, finding max and min. So your maximum and minimum will always be at the vertex of your point. Okay. So if they're asking what is the max or min, all you have to do is find the vertex. Okay. Now when we're looking at this one, we see that the very first thing is a positive. It's positive 3x squared, which means that we have a minimum. Okay, because it's going to be opening up. And so now we use our negative b over 2a. So negative b value is 36 all over 2 times the a value, 3, which gets us a negative 6. Okay, so that means our answer is going to be negative 6 comma something. And now we plug in negative 6 into each of the x values, okay, which gets us 3 times 36, negative 6 squared, plus 36 times 6, minus 8. Okay. And now you would simplify this all the way through, and you see we get a negative 116. And our minimum would be at negative 6, negative 116. Okay. Pretty straightforward. All right, so let's look at an application. So Dr. Pendansky is firing rockets off at Camp Green Lake. Armpit, being the bright math student that he is, calculate the function to find the height of the rocket at any given time t. Given the function f or h is equal to 64t minus 12t squared, when will the rocket reach its maximum height, or its highest point, and how long will it go, or how high will it go? And so what we're asking is basically what is the highest point? Well, if you shoot a rocket, its highest point will be at its vertex. Okay. So we've got to find the vertex of this function. And so what is our b value? Well, our b value is 64. And then our a value is negative 2, or negative 16. And that whole thing's negative. So after we calculate this all the way through, we end up getting about 2 seconds. So at 2 seconds is when the height is when we reach our maximum height. We take the t, plug it into both those t's, and we calculate, we get about 64 feet. So the rocket will go about 64 feet up in the air after about 2 seconds, and then it will come crashing down 2 seconds later. Okay? All right. So again, once you have it, you just use vertex, highest point. All right, so IRAT. Identify the max or min of each. So identify if it is a max or min, and then write what the max and min is. Okay, so find the vertex of each of these, and then find the y-intercept and the axis of symmetry. So for both of these, you're going to have 3 answers each. You have your vertex, your y-intercept, and your axis of symmetry for each of them. Okay? All right? Simple.